All right. Hello, Jason. Welcome to my podcast. It's a pleasure to have you on.
Thank you for having me.
All right. So I reached out to you. This might have been maybe a couple months ago at this point,
Yep.
because I follow you on X and you post a lot of really interesting things. One of the things is Instructor, which you founded. That's why I had reached out to you, because I'd really like to learn about that and your story and journey through that. But before I do, I'd like to just make a quick introduction into you. So you went to the University of Waterloo, right? You got a bachelor's, was it, in computational mathematics and statistics?
Yep.
Cool. And then after that, you did a wide array of things. So you were a research assistant at NYU. You were a data scientist at Facebook. You worked at Stitch Fix as a machine learning engineer for about 5 years. And that's a very particularly interesting timeline, because you were a machine learning engineer from 2018 to 2023. So you went pre and post this interesting large language model development. Then you worked at South Park Commons, where you were currently on a sabbatical, and you do personal consulting, right?
That's correct.
Okay, cool. So can you tell me, I guess, a little bit of how was that journey into engineering, into mathematics, into machine learning for you? And how crazy is it that you stacked yourself so perfectly for what's going on right now, that you basically have the foremost expertise almost, and just perfectly plugs into that. Can you tell me about that experience a little bit? I'd love to hear it.
Yeah, sure. So when I actually entered the University of Waterloo, my goal was to study theoretical physics. And what I had found was that the timelines it took to do the research was just way too long for what I wanted to do. Research takes like 60 years to do that. I'm like 19 years old, 4-month internship on a 40-year project. It didn't really make any sense to me. And so I really transitioned into learning machine learning throughout college as a way of still doing things like science and reasoning about problems and building models of the world, but using machine learning rather than using the laws of physics. And so what I found was because we didn't really have a machine learning program or even data science at the time, I went into computational mathematics and statistics, started a club there, and kind of grew out the community as I went up the years in university. And yeah, my research has mostly been in recommendation systems, computer vision, and social networks. And funny enough, I was like very bearish on the large language models. So when I had trained like GPT-2 on my laptop, it was very much like, oh, this is like a cute toy. It can write like a Shakespeare sonnet. It can write like a 50-cent rap lyric. Okay, I gotta go back to my real job, make some money, build computer vision models, fine-tune vision models, and build recommendation systems. So, even though it may have looked perfectly planned, I was actually very surprised near the last in 2022 when ChatGPT came out. That was a big eye opener for me, and understanding that the world really changed.
It has, I think, in more ways than we can even imagine, and it's changing right now, right? I don't think that the pace of change is going to stop. It certainly seems to be accelerating. What's crazy to me about the large language model stuff is that it perfectly plugs in to whatever's going on right now in the terms of the infrastructure, the talent, you get what I'm saying? Like, imagine if the Industrial Revolution happened, but then we had everything just ready to go and everyone was like, yeah, let's do this. That's what I feel like is going on right now, because this is an innovation that can use the existing infrastructure, but then also improve it as well.
Yeah, I think it's really well timed, especially as like even when you think about things like the layoffs, for example, in like the tech world, the fact that now we're in a situation where there are plenty of people who are like not even having to decide whether they want to quit their jobs. Now they're all free to play around with these ideas. And now a lot of like startups and a lot of like generative AI startups have formed as a result of even something as big as like the economic conditions that we had earlier last year.
That's actually a really good point. I didn't think about that. You have all these incredibly talented people that just got laid off. And yeah, you're right. Not only that, but if you have any sort of competence in in thinking a little bit abstract and a little bit of technical, you can then use the large language models to be essentially like an artist and create things that don't exist. It's just there hasn't been enough time for all these different avenues and people to get their hands on it. And that's one of the things that I see in the large language model space, I think, is there's much fewer like enterprise grade, like consumer grade applications due to the non-deterministic nature of the responses that you get. But I think it is just a matter of time. It's just a lot different, and I think a lot harder than everybody thought, because Chat GPT seemed like this magical thing that kind of just could do whatever. Where do you think we are in the, I guess, as a society with this technology? Where do you think we're heading, and what kind of role do you want to play in this upcoming revolution, or existing, whatever you want to call it?
Yeah, I would guess one thing to talk about in terms of the enterprise products is really the fact that because there's such a long tail of problems, it's very easy to get the demo up and to raise the money. But it's actually very difficult to actually go out and build something that works, 99% of the time, right? Like, you wouldn't want to release a product that says that you can like set an alarm clock and then have it only succeed, half the time. It just wouldn't work as a product. So I think that's kind of one of the big things that people are really facing these days. In terms of where I think they're going, I think the majority of people have really concluded that agents don't really work that well, and retrieval augmented generation is kind of the trajectory of many different companies, right? And that's actually kind of nice, because really retrieval augmented generation is just building good search tools, building good retrieval, and thinking about it almost like personalization or recommendation systems. And so I think in the next couple of years, the people who have been like locked up in the ivory tower of tech are going to be able to like leave those jobs, come into the Gen AI space once it's more proven out. And I think that's where the larger advancements are going to come in, once people really understand that this is not a toy or a demo or something a little bit more serious.
I think you need a lot of trial and error, because like you said, it is pretty easy. I've built a few demos myself, doing really cool stuff with GPT models and large language models, just with a simple Python script, right? You have some Python and you have some interesting way to implement it, like some data visualization, or how you can convert natural language to SQL queries. You can take that, parse it out, and do really cool, interesting things. And then when it comes to, okay, well, how is this useful for somebody? It's like, okay, well, what about security? Like, do you create a data semantic model sitting somewhere, or do you keep it on a server? Is it your server? A lot of these like traditional engineering challenges come along, that I think definitely will be solved for long term. And there's probably people right now doing cool things. Like, did you check out the Rabbit R1 keynote that just came out?
I already ordered one.
Oh, you did?
Yeah.
Wow. Okay, cool. That was quick. What do you think about that?
I mean, I don't know how seriously I can really take any of these toys like Humane and Rabbit, but I think a lot of it has been just as someone who is participating in the space, I just really want to see what people are really tinkering with. They talk about this like large action model. In my opinion, it really just feels like some kind of function calling framework. But again, I think only time will tell once we actually get our hands on these things and figure out what are the technical things that they've really tried to solve, what's the hardware that they've built to solve that problem, and how those things kind of really get to exist as a business is something very exciting to see moving forward.
Do you think function calling is enough if we solve for data structure, meaning extraction of data structure back from the response?
No, because those are two really separate things. I think extraction is mostly just around reasoning about the shape of the data, whereas function calling, as it's supposed to be used, is really thinking about, given a world model, what tools do we have access to, and how do we choose those tools correctly? And so the kind of training data we need is very different, right? Structured extraction data is very easy to come by. I can make up a JSON object and then convert it back to unstructured text, and then I can have a data set that says, well, pretend to be one or the other. Whereas if we're trying to do something that's more agent-based, you really need almost like a world environment for it to sort of do some self-play and simulate these decisions, and also understand what the consequences of these decisions are.
What do you mean by world environment? How do you envision that?
Yeah, so Structured extraction just might look like given, a receipt, give me the data back out. Whereas an environment where you need to have actions, it's unclear how we can book an Uber, right? Do we do that because we have access to the Uber API, or is it because we have given it access to a vision model and it's able to see the screen, understand what buttons are, understand, when a request was being made, when a car needs to get picked up? All these different things really have to come from a simulation or an environment rather than just sort of the structured data that comes out.
Do you think there's going to be a fundamental shift maybe from retrofitting and more to let's break things down and rebuild it?
Ultimately, as with any technology, right, the existence of the ebook did not really deprecate the printed book, right? The existence of electrical cars won't really deprecate, gas cars. And if you think about how long it might take for us to get rid of gas cars or printed literature, it's going to be a really long time. And so for the most part, I think it's really going to be less around whether or not one or the other will win, but sort of how we can adopt this technology and whether or not any of these products make sense. Right? I'm out here in Canada right now. It's super cold. Even electric cars don't make that much sense when, batteries, for example, have these limitations inherently in these systems. Yeah, I think only time will tell whether or not the early adopters actually find a good use case for these things, especially because, for someone like me that got Rabbit, I simply got it because I was very curious, not because it's actually solving some burning need that I have. And, maybe I'll be shown what that burning need is, but only time will tell.
Interesting. Okay, that makes sense. So go at it from all angles and may the best version succeed, and maybe multiple versions of everything concurrently existing. Okay, so I would like to talk about Instructor. This is something I was really interested in because I mentioned earlier, I've been building some demos, and I've been doing a lot of prompt engineering in order to get the structure that I need from the data. What interested me about Instructor was that it seems to be a much more concrete way to get structure out of a large language model response. Can you tell me what is Instructor, and why did you start building it?
I would say Instructor isn't that much code. I think the goal of Instructor is to provide a minimum intervention API over what exists right now with large language models. And what I mean by this is just simple things like defining different types, right? If we can define types, programming with language models feels more like you're working with an IDE. If you have validation, you have more confidence that at runtime, the data that you get back out from the language model makes sense. And then thirdly, being able to re-ask these language models when validation fails, right? So by defining the response model, supporting validation, and supporting retries, you build a system, or at least you build a framework that is much easily backwards compatible with existing code, right? Functions already have structured inputs and structured outputs, right? Databases are structured inputs and structured outputs. API calls are structured inputs and structured outputs. And by introducing these three concepts, right, the response model, the validation, and the retries, we get a really simple framework to reason about these things. And so the goal for the future really is to do this in Python, to JavaScript, and in Elixir, and then build out this very simple standard across many different language models and many different programming languages.
How does it interact with something like Pydantic?
Yeah, so this is where something like validation comes in, right? In JavaScript, you have Zod. In Python, you have Pydantic. The main goal really is to hook in what is already a very native framework for validation and not really have to invent new standards and get in the way of other developers, right? Zod has 70 million downloads a month. Pydantic has 130 million downloads a month. These are libraries that are very trusted and well-maintained. And so it allows us to really not have to reinvent the wheel when it comes to things like validation.
Can you give me, what's the simplest example that you can walk me end to end? What happens? I'm plugged in. I got my OpenAI keys. Everything's ready to go. Instructor is there. Pydantic's there. I click send, right, to and ask a question about something. How does it get parsed out? What's going on behind the scenes?
Yeah. So these different language models have different ways of returning structured outputs. There's things like JSON mode, there's function calling, there's tool calling, and what Instructors allows us to do is really natively switch between any of these different modes, right? Some language models might only support function calling. For OpenAI, tool calling is now supported, but function calling is deprecated. In AnyScale, for example, it supports JSON schema on top of JSON mode. And so Instructor manages that all behind the scenes. And so depending on the mode, it will take that response object that you want, we'll turn it into the JSON schema, and we'll send that to the language model, whatever way the language model prefers. And we just make sure that we can parse that data back out and validate it on the at runtime.
I see. So it's really about taking an existing structure like JSON, and if you need it, switch back and forth at will, essentially using Instructor. Is that what it is?
Yeah, right. Like, when we load in data from a CSV file, the CSV itself is just text. Like the commas exist, but the commas only exist as much as any other sort of character in that body. But when we actually load into Excel, Excel will actually figure out, okay, these are the columns, these are the rows. Let's do some formatting, all that kind of stuff. And so JSON is kind of this idea of the CSV, whereas something like Pydantic and Zod gives you more capabilities and actually give you the representation of a table rather than just a text file where everything is baked into the text.
I see. And so do you, is it reliant on the language model to give a certain format still? So if I'm prompt engineering, or do I have to call a function? Do I have to do JSON mode? Or how does that work out?
Right. So if you set the mode in Instructor, that is all handled behind the scenes. But ultimately, everything that we're asking and sending back and forth is in JSON.
Mm-hmm. Okay. And what I know you work with quite a few, I guess, clients you would call them. So Rewind AI, Modal Labs, New Computer, and there's a lot more. What kind of interesting things are you seeing Instructor applied to?
Well, a lot of it is just, again, making the code easier to manage, right? Like Instructor is simply adding these type hints. And what this means is that it's very easy to integrate something like Instructor in existing code bases, right? We start treating language models as just another piece of code rather than this very special class of things. If we use an ORM, for example, we don't have to write SQL anymore. And the ORM gives you the ability to write SQL behind the scenes. It also might give you the ability to return, like, Pydantic objects or Zod objects back out that are typed. Right? All it does is it makes these things a lot more convenient to work with without having to reason more about the boundary between the code that you write and the language model that you call.
When somebody, so you do consulting now, right? When somebody reaches out to you, I guess, what could they expect from working with you? Like, I guess one is, how do they reach out to you? Do they tag you an X, or do they shoot you an IM? Like, how do you get people to know about you, to know about Instructor, and want your service in the first place?
Yeah, I guess Instructor is very separate from the consulting that I do. Most of my consulting is mostly around like tech strategy, like infrastructure, and a lot of like technical writing. I would say most part people will either have known me from Twitter or reach out directly through email. And the general idea is that, we'll do some calls. I'll write up what we call like a situational assessment. I try to understand what your business is going through and trying to figure out, what are the objectives, what are the metrics, and what are the, outcomes we're looking for. And we just apply a mix of like data science, software engineering, and strategy to sort of try to get you there.
Okay, got it. And without going in any details, obviously, to not talk about exactly what people are doing, but are you seeing some like really cool, interesting applications that you wouldn't have thought are being worked on through the way that you're consulting?
For the most part, not really. I think the products are very clear, right? There is a lot of room for personalized data. There's a lot of room for doing things like, companions or assistants. I think the most important thing is you just understanding that what you're building is just going to be a good product or a bad product, and focusing on the product and the business you're trying to build is much more important than thinking about sort of how you're prompting a specific model or which model you end up using. Because once you build the product, once you have the users, once you have the business, it will produce the data you need to train the models you will deploy in the future.
Okay. Yeah. So you go high level, like what are we trying to achieve, and then you fit everything else into that. Do you curious? Do you build your own personal tools? I know you're working on something called Journal, right? And
Yeah.
I would assume that it has a personal use case. Do you do stuff like that to technologically, I guess, augment yourself?
I try not to sort of spend time doing these things these days. I mean, I haven't really touched a journal since April, but it is still something I use, on a weekly basis.
Hmm.
I would say for the most part, because I'm really interested in trying out these new tools to understand what the market is going, I haven't really focused too much time on sort of building these tools myself.
Okay. What do you spend your time doing? I noticed that uh, you wrote that you're currently cycling your time between artist and tinkerer.
Yeah.
What kind of
So I
things do
mostly
you
spend my
occupy
time
yourself with? Sorry?
you know, like playing the trumpet.
Oh, nice.
I would say for the most part, I spend my time between like writing. I'm really working on sort of trying to be a better writer, being able to express myself. Some of my time is spent doing like pottery and jujitsu. Hopefully, when the weather gets nicer, I'll do some free diving. Really just trying to find a balanced life.
Pottery, jujitsu, writing, and you also wanted to be a theoretical physicist. That's what an interesting mix of things. And if on a personal note, I physics is something I greatly admire. What made you want to do theoretical physics?
I mean, it just seems like if you're gonna be if you're curious and you want to be the most curious person, I think the end ends up being like the entire universe, right? It feels to me, it felt very obvious. Like if I wanted to know everything, like if I can know theoretical physics, I probably know a lot of other things as well.
Do you still follow it? Like layman's at least follow it?
Not too much. It's also one of these things where the timescales again are so long. Like the the volume of work that has been happening before I was born and from when I was born to now, it's like really very large scale projects that take a long time, right? I think we a couple years ago we measured like gravitational waves. Right? I haven't really seen too much big news recently. Um, Now people just think there's aliens, but for the most part, I think once I decided to leave and focus on machine learning, I primarily spent my time doing that. And then when I took my sabbatical, I was mostly just messing around, having fun with my life.
Hmm. What have you learned from machine learning? What is that discipline like? And for context, I don't have any background in it at all.
Mm.
So, what is that field like? What's it like going through it?
I think when you enter, you think that there is structure and theory that explains how things can work and how things can work better. I think that's the physicist approach. And it's happening now where there's these ideas of like scaling laws, right? Like for this much compute, for this many tokens, there's just an idea of what is the optimal model to train. But I think the thing that really struck me maybe like 1 or 2 years into doing this kind of work is that it's so empirical, right? It's very hard to figure out what is the right design coming in. It's very much like, well, we don't know. So let's just run these experiments and figure it out. And once we get these experiments, once we get these results, then let's build a conclusion as to what has been performing well or not. That's why, for me, I always say like the most important thing is to first collect this data, because any of these questions that we ask ourselves, there's really no underlying theory that can tell us, or at least a predictive theory that can tell us exactly what's going on.
Interesting. If you had to describe machine learning, how would you describe it?
Is just building data sets. Right? The idea is that if you can build a data set and then you can train to make a loss function that can predict that data set, you will do well. If you don't
And
have a data set, if you don't have a loss function, there's likely nothing that you can do. There's no productive work that you can produce.
what is the loss function?
Yeah. So the loss function is basically the idea of how wrong am I? And given how wrong I am, is there a way for me to figure out how to improve my answer? A simple example could just be predicting the price of a house. Maybe I have some bedrooms, I have some bathrooms, I have the square footage, I have the year the house was built. And what the loss function basically does is it says, okay, if the house is $1 million and I guessed it was $500,000, I was wrong by $500,000. Not only that, my prediction next time should be higher, right? And that's kind of how gradient descent works. And so the price of a house is really easy to figure out because it's one number, right? And usually if you just took the difference, you're doing okay. right? But what is the loss function that converts a picture to a prediction of whether it's a dog or a cat? It's a lot more complicated, right? What is the loss function of predicting the next word in an LLM? A lot more complicated. What is a loss function of a good poem, right? You can see how you get much more complex problem that you're solving, right? But ultimately, it comes down to just building out the data set and just figuring out what that means, right? Maybe I can't figure out what the loss function of a good poem is, but what I can do is I can go hire people. I can hire English teachers to read literature and grade whether or not one poem is better than the other, right? Now, I might have preference data, right? Now I only have the ability to compare two poems and figure out which one I like more. But that is enough to start building out a model, right? Because I've curated the data set. And a lot of machine learning will end up being, how do we build that data set? And then how do we build the model that can predict, this loss function?
So when I think about like a generative pre-trained transformer, the GPT models, that is essentially a branch of machine learning that trains on text, and then you determine how accurate you are versus a certain task, which produces a loss function. Is that correct?
Yeah, so if you're trying to predict the next word in a sequence, like I am a very happy, you might imagine this next word would be person, right? But it wouldn't likely be the word trumpet. And if you guess trumpet, how do you tell it that it was a bad response, right? Yeah, a lot of that ends up just being like, what model architecture you're using, and then how do you curate that data again?
And you did that for like 5 years or so, right?
Probably does like 10 months.
Well, how long?
Even as a data science and as a research assistant, and even in college, I was like teaching and doing machine learning.
Okay. Did you see a lot of progress in that field for that duration of time?
Yeah, I mean, in like 2017, we were making huge progress by being able to predict like handwriting, right? We were able to predict like whether something was a dog or a cat. Later on, we could do things like draw boxes around the items and maybe do a product search. Maybe we could even caption some work, right? In 2018 and 2019, we had things like style transfer. If you even look at something like Midjourney and you look at V1 that came out in 2022 and the V6 that came out this week, the differences in quality is like astronomical. But if you actually think about the scope of all machine learning problems, it's still very limited. Right? We're just learning how to do text to speech and speech to text. We've just recently been able to, synthesize something that sounds like music, right? So when it comes to that, something like Whisper in terms of video captioning, it feels very straightforward, right? But I'm still waiting for the world where I can just give it, an orchestration, right? I can give it Mozart and just say, well, transcribe it for me. Give it to me in the form of sheet music, right? I couldn't do that. I could take a photo of sheet music and say, okay, play the music for me. Like synthesize both the oboe and the trumpet and, do all that. I couldn't then take the sheet music and say, well, now give me the video of the person like conducting the orchestra, right? In terms of what is possible in Gen AI, I think there's a lot of work that people probably aren't doing because we don't have that data, right? We don't really have the data of like sheet music to conductor. But I think if there is a world where there is Gen AI, I would really love to learn to play the trumpet by just passing an AI like videos of people playing music and just say, hey, transcribe this for me. Tell me what the notes are and show me how to play.
Do you think that's coming?
Probably not. I mean, I think for the most part, again, it really comes down to having a team that is motivated enough to produce that data, right? Audio to transcript is very simple because we have YouTube. We have millions and millions of videos, millions of hours of videos where we have the captions and we have the content. It'll be really easy to train a model that, looks like a podcast because there's plenty of podcast data out there. Right? It's probably going to be very simple to fake my voice as more podcasts exist. But the odd branches of problems that people are solving is really just a limitation of the data that we have.
I'm wondering if it's possible to, once you have a competent enough and I guess strong, for the lack of a better term, model that can produce maybe even just a sample of what you just said, and then give a few iterations of it, and then have it kind of expand in in all the different, I guess what I'm describing is synthetic data, right? I could see that being a pretty probable thing. So I wouldn't want to sit there, take videos of trumpets and do what you're saying, but maybe if you just do it once or twice and then, you pass it on, be like, hey, use this thing, and then kind of guide it along the way. I'm wondering if something like that would be prevalent in the future.
But like, if you ask me to create synthetic data, the music I'm able to play is very limited. So the data that I would produce is also very limited, right? Like, you would need an equally strong model in synthesis to build something that extrapolates new information, right?
Yeah,
like,
right. Or
there's no way you could give you and me a trumpet and we couldn't get all of jazz, right? There's just no, it's not within us. And even if we are intelligent, right, the likelihood that we can even compose something like that, let alone teach each other that process, is very difficult, primarily because there's the loss function for good music is a very difficult loss function. But something like playing chess is very simple, right? We could, in fact, sit down and figure out chess because we know what it means to win, right? But when you do something as subjective as something like music, you can imagine it's much more difficult.
There's got to be some cheat codes in there, because Beethoven, that guy, was producing incredible music while not being able to hear, but that's because he understood the mathematical correlations between the notes, and so he just kind of did this. So I'm wondering if there's a little shortcut in there somewhere, because large language models, you can ask them for a certain style, which is what the super interesting thing is. You can ask them for a certain style of whatever, poem or song or whatever, and it does a pretty good job, like GPT-4, obviously, to kind of reproduce that. So I wonder if, given enough time, you could kind of create the correlations. Like, okay, what do people find pleasing? Well, it's half notes, and I don't know music terminology, but you could do these mathematical formulas. I wonder if that's I don't know, what if that would go anywhere.
If you use formulas, then the music would be formulaic, right?
Yes, but do you think there's
what you're doing is, if you give it the formulas, what you're saying, your loss function is to follow these rules, right?
Mm.
But I can write sentences using Mad Libs, but it's not going to look like GPT-4.
Right. So do you think people put in a certain I guess, I don't know if it's soul or emotion, or how do you think we do that? How do you think we transcribe emotion and stuff like that into a song if it can't be captured in a simple formula?
I mean, this is going more on the philosophy of art, but
Yeah.
usually Walter Benjamin has this belief of aura, right? It's the reason why a painting from Van Gogh looks different than or we perceive the work of Van Gogh differently than we perceive a photograph of Van Gogh's work, or even an AI generated version of that work. Right? It's the aura that we carry, that we bring to the work that matters.
An aura. What kinds of things do you do that you put your aura into?
Probably just everything, right? I mean, I am a live person, so I think that everything that I do has some form of that aura, right? I think if you look at people who play music or do martial arts, I think the friends that I trained with, probably if they saw a silhouette of me fighting, could tell that it was me. Right? That style, and that is something that we carry. The way we do anything is the way we do everything, and I think that comes from the personality that we have, and the thing that we imbue into the work that we do is that aura.
Do you think these generative models can start producing their own auras?
No, I think for the most part, you could imagine a world where humans can take the work and do the aura, but it's the same thing as whether or not someone makes a cup by hand, or if they use mold, right? You could you could convince me that the version of the mold has aura, but you can also convince me that it doesn't, right? These are all very subjective things.
Okay, so you're saying, at least in our subjective experiences, the fact that we know that something was made by hand versus a machine, that is an attribute in and of itself that gets computed in our brains as something really meaningful, right? Is that what you're basically saying?
Yeah, right. If you're like drinking from a wine glass, and I told you that wine glass is $1,000, and I told you that I lied, then it was $2. Your perception of the object changes.
Okay. So you like philosophy. I noticed you posted about bad faith the other day.
Yeah.
Could you tell me what that was about? I was actually very curious.
I mean, as just someone who like worked a lot when I was younger, I think it's in bad faith to believe that like you are just your work. And so one of the things that I do is like I do all these other hobbies as an attempt to live in good faith, right? Like bad faith is to believe that you cannot like transcend your. This is like still very new to me, but I think the general idea is that you cannot transcend like who you are, and you believe that the purpose of your life, for example, was like predefined, right? Like it is like the example that like Sartre says is like it is bad faith for the waiter to think he is a waiter. I'm not really sure like in what context you saw this from, so I don't know how to make it relevant for the conversation that we're having.
No, yeah, you're right. Sorry, we just went a little philosophical, and I had noticed you said that, and that kind of stuff is interesting to me because we're all on our own like weird journeys, and we all need mechanisms to make sense of this of existence. And I thought that I just think it's interesting to see all the different angles from a person, especially you who is a very technical person, but then you kind of go from all different angles in the way that you post about your life and your experiences. Is that how was that journey for you in more or less, you have X amount of people who follow you. So whenever you post something or do something, that a lot of people are seeing it. How is that psychologically for you?
I don't really think about it. Like in April, I had 400 followers. I told myself I wanted to get to 10,000 followers. I found out that, for every tweet I make, I get 1.5 followers. So I just had to have 10,000 tweets, right? I think that's the thing I really talk about a lot on Twitter is focusing on the process goals rather than the outcome goals, right? Like the process is just like number of words I write down a day. Like if I want to write, it's number of words. If I want to develop social media, it's just a number of tweets. Everything else is functionally a distraction.
Interesting. Are you pretty strict with your like schedule and the way you organize yourself?
Nope, not really.
Huh.
Because again, I just have to ask myself, like, did I do the things? It doesn't matter like when you do the things, right? Like, if you're trying to lose weight, people have things like skipping breakfast or intermittent fasting or, vegan or keto and whatever. But ultimately, the consequences of those things is just less calories, right? The way with which you do them is different. But chances are, if you became carnivore and you lost weight, it's probably because you ate less calories. If you went like carb only and you lost weight, it's probably because you ate less calories, right?
Right.
And people have these like superstitions on how to do things, and they have like attachments to the outcomes of like being skinny or like being hot. But I think the only real thing you can measure is the process goal, right? It's really just calories in, calories out, and like how much you work out. And so when I'm building up my social media, the only thing you should be tracking is like how much you're working out, not how many followers you have or whether or not I think people are looking at you.
Yeah, if you build it, they will come type of thing.
But it's also like, even this idea of like, do you worry that more people are looking at you? And it's like, well, if I go to a gym with more people, that shouldn't really change the way I work out. Right.
Yes and no, because the gym analogy, everybody's there working out. But there's something.
Yeah, everyone's on Twitter tweeting, right?
Yeah, that's true. No, you're right. You're right. But
nobody's like coming to Twitter to like check out my writing. My writing just happens to be on Twitter.
Right. Yeah. It's floating in the sea of algorithms, just flying by everyone's screen. Very cool. So what are you up to next? What do you plan to do in the future? What's on your radar?
I mean, for the most part, I think my goals are just going to be like getting Instructor to a good place so we kind of have like the mission statement, and then supporting other developers and building it out for their language, right? Instructor is such a lightweight system that it only took, I think, 40 hours of work to go from like an empty GitHub repo to a version of JavaScript for Instructor. A buddy of mine has been spending like a week and wrote the Elixir version. I think it'll be really simple to get this pattern out in front of a lot of people. And then my only job is to sort of promote and market those libraries. And then personally, right now, I'm just, at home waiting to get my O1 visa so I can go back to the States and, see my friends.
Okay. And you're in Canada now?
Yeah, I'm in Toronto.
Okay, cool. Well, good luck with that process. I hope that it's swift.
Paperwork goes in on the 15th.
Right. Yeah. There's probably a lot of emotion that because an O1 visa, and that is specifically. Could you explain what that is? I've heard the term, and from my understanding, it's. I'll let you go if you.
Yeah, the O1 visa is just like the extraordinary ability visa. So I basically have to like prepare this document that just says like, hey, the U.S. would benefit from me being in the U.S. So it feels a little bit outrageous because you have to like really come to terms with your own ego of like, oh, like what if I don't get the visa? That just means I'm unextraordinary. But I would say for the most part, it really is just a matter of showing that you are an expert in your field and that your presence in the U.S. can benefit.
Wow, that's pretty intense, to be honest.
It's a very strange feeling. Yeah, so it's a lot of like news articles. You get like a lot of famous people to write you letters, stuff like that.
Wow.
Yeah.
Very cool. Well,
and having a lot of Twitter followers probably helps. So
that's true. So it's not exactly the gym reference, right? It does have some sort of higher meaning. Well, hey man, listen. Good luck out there. I hope that works out for you quickly. I hope you get that visa going. I love what you do. I love what you write, the philosophical stuff and the technical stuff. Thank you very much for sitting down with me and talking to me today. Sorry, I didn't hear. I think I talked over you.
Yeah. No, I just an article got popular on Hacker News, so I was just kind of playing around with the guys on Hacker News.
Nice, very cool. All right, man. Thank you, Jason. It was great meeting and great talking to you.
Great meeting you too.
Have a good one.
Take care.